This is lesson 4, and the topic is linear equations. One of the first things you have to understand about linear equations, though, is some background information before we can actually get into discussing specific linear equations. So let's begin by talking about the xy coordinate plane. You all should be familiar with this. As you can see on the screen, we've got a horizontal axis which represents the x values, and a vertical axis which represents the y values. So any point on this plane is going to have an x coordinate and a y coordinate. So basically what we've got is two variables here, an x and a y. Now the general form of a linear equation is always going to look something like this. ax plus by equals c, where a, b, and c are real numbers, and x is a variable and y is a variable. Now, why is this referred to as a linear equation? It's referred to as a linear equation because if we would graph it on the xy coordinate plane, it would graph as a straight line, okay? So whatever the values are of a, b, and c, that would move it around somewhat, but regardless of what those values are, when we would pick points and solve the equation for x and for y, we would find that it would be a straight line, hence the term linear equation. So here's a typical example of a linear equation where I've picked values for a, b, and c. Let's say that I've got 3x plus 2y equals 4. This, by definition, is a linear equation. Now, if you were asked to graph this on the xy coordinate plane, you would simply pick points. You would pick a value for x, plug it into the equation, and solve for y to see what the corresponding y value is. Pick another value for x, plug it into the equation, solve for y for that particular point. Now, since this is a linear equation, in reality, all you have to do is plot 2 points and connect them with a line. However, it's advisable that you plot 3 points just in case you make a mistake. Because if you plot 3 points and they do line up for a single straight line, then you know that most likely you are correct. However, if you pick 3 points and it isn't a straight line, then you know one of the points is actually in error and you should go back and check. Now the easiest points to pick are obviously 0 for x and 0 for y. So you could plug in 0 for x and get 1 point, and plug in 0 for y and get another point, okay? So let's look at our equation here. We got 3x plus 2y equals 4. If x is equal to 0, if I plug in x is equal to 0, I've got 3 times 0 plus 2 times y equals 4, or whenever x is 0, y is equal to 2. Now if you look at the graph, you notice I've marked that point with a red x. So when x is 0, y is equal to 2. Also, another thing to remember is whenever points are identified on the xy coordinate plane, the x value is always given first. So the coordinates of this particular point would be written as 0, 2, okay? The x value is always first, the y value is always second. Now if I plug in y equals 0, I'll get 3x is equal to 4, or x is equal to 4/3, or specifically 1 1/3. And again, on the graph, I have marked that point. So that point would be correctly identified as 4/3, 0. Okay? So those are my 2 points that satisfy this equation, 3x plus 2y equals 4. Now I could simply draw a line connecting those 2 points, and I would have all the possible solutions for this equation, 3x plus 2y equals 4. All x and y values. Because notice, This is a line, so therefore there's going to be an infinite number of solutions that are going to satisfy this equation when you have the two variables. It's not like an equation with one variable where you typically will have, say, one or a specific number of solutions. Here you're going to have an infinite number of solutions that are going to satisfy this equation. So as you can see, we've got a line that, as you go from left to right, is going down, and it goes through those 2 points that we already talked about. Now, one thing to note about our line is that, first of all, notice these 2 points that we picked, okay, where x is 0 and y is 0. Those are referred to as the intercepts, okay? Where it crosses the x-axis is referred to as the x-intercept. It's where y is equal to 0. So the x-intercept is where y is equal to 0. Obviously, where it crosses the y-axis is going to be the y-intercept, and that's where x is equal to 0. So the y-intercept, the coordinates of the y-intercept are 0, 2. The coordinates of the x-intercept are 4/3, 0. Okay? So intercepts, we need to understand what their definitions are. Now, another thing to note is the slope of our line. Notice, as you go from left to right, it's basically going downhill, all right? So, there is something referred to as slope. Now, slope can also be referred to as steepness. And it is most often referred to by the letter lowercase m. So if you see lowercase m most of the time, or typically, that is the slope. Now if we use our general form of the linear equation, ax plus by equals c, by definition, the slope is equal to minus a over b, okay? So by definition, the slope of a general linear equation, ax plus by equals c, is minus a over b. So now let's take our general equation, ax plus by equals c, and let's solve that equation for y. So we've got y equals something. So initially, if I subtract ax from both sides, and then I divide everything by b, I'm going to get the following. So now I have y is equal to minus a over bx plus c over b. Well, let's look at this general form and relate it to our example of 3x plus 2y equals 4. Now, notice something here. First of all, let's look at c and b. In our example, c was equal to 4, b was equal to 2. So 4 over 2 was equal to 2. So c over b happens to be what? The y-intercept. That's where it crosses the y-axis at y equals 2. Let's look at minus a over b. We were told by definition that's the slope of the line. So I could rewrite this equation now in what is referred to as slope-intercept form, and it would look like this. Y is equal to mx plus b. All right, so notice what we've got here. We have m right here. This is going to be the slope of our line. And we've got b, which is the y-intercept. So if we change our equation to put it in this form, y equals mx plus b, we immediately know what the slope of the line is. We know what the y-intercept is. Now, a point of interest here is the fact that, let's look at our original example here. A in our example was equal to 3. B in our example was equal to 2. The slope, we said, was minus 3 over 2. When the line is going downhill from left to right, that is considered to be negative slope, and the slope is going to be negative. If going from left to right, the line is going uphill, then that is considered to be positive slope, okay? So if the line is going down, it's negative slope. If the line is going up, it's positive slope. In addition, we have the y-intercept. So we know an awful lot about a linear equation whenever it's in this form, y equals mx plus b. We immediately know the slope, we immediately know the y-intercept, and it's very easy to graph it at this point. So let's continue on with our discussion of slope. Another way of looking at slope is slope is equal to rise over run. So if you think of a right triangle, rise would be the vertical displacement, run would be the horizontal displacement, and that would be a measure of slope, or if you could also think of this as being the angle that we've got right here, okay? So slope is equal to rise over run. Well, let's take that a step further and think back to our xy coordinate plane, and what is rise equal to? Rise is simply equal to the change in y values, okay? Well, we've got y2 minus y1. So that's this displacement, or rise, is just the change in y values. If you got 2 points, the y value of one point minus the y value of the other point. Similarly, run is equal to x2 minus x1, or the change in the x values here. So you can if you know 2 points, you can calculate the slope by saying y2 minus y1 over x2 minus x1. So now let's look at an example. Let's say I have 2 points on the xy coordinate plane, 3, 1 and 2, 2. And I want to know what is the slope of the line connecting those 2 points. So by definition, the slope m would simply equal 1 minus 2 over 3 minus 2, okay? Now, notice I picked the 2 value, y2 as being 1, 2 being y1. I could go the other way so long as I am consistent. I could have said 2 minus 1 over 2 minus 3, okay? But so long as you're consistent, it doesn't matter which way you go. All right, so what does this give me for a slope? So this simply gives me minus 1 over 1, or minus 1 is the slope. All right, next, how would I go about getting the equation of the line that connects these 2 points? I know what the slope is, but I want now the full equation. So let's start with the slope-intercept form of the equation, y equals mx plus b. I know what m is equal to minus 1. But what is b equal to? Well, I have two points here that I can use to plug in for y and to plug in for x. Notice, I could use either 3, 1, or I could use 2, 2. Now, for no particular reason, I'm going to use 2, 2. So now, if I plug in 2 for y, right here, and 2 for x, right here, and minus 1 for m right here, I can solve for b. And I end up with b is equal to 4. So therefore, the equation of the line that connects the 2 points, 3, 1, and 2, 2, is y is equal to minus x plus 4. We figured out what the slope was connecting those 2 points, minus 1. We plugged that into y equals mx plus b, along with the values for x and y from one of these points. I could have used either one, and solved for b. I got b equals 4, so therefore y equals minus x plus 4 is the equation of the line connecting these 2 points. It has a slope of minus 1 and a y-intercept of 4. It goes through the point 0, 4. So now, what if I had another equation which had the same slope but a different y-intercept? Say I had something like y equals minus x plus 2. What would we know about those two lines? Well, if they got the same slope, they must be parallel. So, whenever you have two lines that are parallel, they are going to have the same slope. So, what about perpendicular lines? If parallel lines have equal slopes, what do perpendicular lines have? Well, we could work it out with two lines that are perpendicular, but the definition basically is that the perpendicular lines, the product of their slopes is going to be -1. Or another way of looking at it is that the slopes are negative reciprocals of each other. So let's look at an example. Let's say I have one line whose equation is y equals 2x plus 1. The slope of this line is 2, right? And the y-intercept's 1. Now, if I have another line that's perpendicular to this, it's going to be a negative reciprocal. So in other words, I'm going to flip the 2 and change the sign. So the equation of a line which would be perpendicular to y equals 2x plus 1 would simply be y equals -1/2 x plus 4. The y-intercept is immaterial here. Basically, all we're concerned about is the slope. The slope of this first equation is 2. The slope of the second equation is -1/2. And obviously, if we multiply these two together, we get -1. So this concludes this lesson. So now move on to the worksheet and see how you do.